Let's see if we can evaluate the indefinite integral of tangent x dx. And so, like always, pause the video and see if you can figure it out on your own. And I will give you a hint. Think reverse chain rule. All right, so you have attempted it, and you might say, well, reverse chain rule, that's kind of you're seeing a function, and you're seeing its derivative, and you can integrate with respect to that function. All you see here is a tangent of x. What am I talking about? Well, whenever you see a tangent of x or a cosecant or a secant, at least in my brain, I always like to break it down into how it's defined in terms of sine and cosine, because we do at least have some tools at our disposal for dealing with sines and cosines, or at least our brains, at least my brain, has an easier time processing them. Well, we know tangent of x is the same thing as sine of x over cosine of x. So let me rewrite it that way. So this is equal to the indefinite integral of sine of x over cosine of x dx. And you could even write it this way, and this is a little bit of a hint. You could even write it as sine of x times 1 over cosine of x. So if you couldn't figure it out the first time, I encourage you to pause the video again, and once again, think reverse chain rule. So what am I talking about when I keep saying reverse chain rule? So let's just review that before I proceed with this example. Because if I were to just tell you, well, what's the indefinite integral of 1 over x dx? Well, we know that. That's going to be the natural log of the absolute value of x plus c. Now, if I were to ask you, what is the indefinite integral of f prime of x times 1 over f of x dx? What is that going to be? Well, here's where the reverse chain rule applies, where I have 1 over f of x. Boy, I would like, if only I had its derivative being multiplied by this thing, then I could just integrate with respect to f of x. Well, I do. I have its derivative right over here. It's multiplying times this thing. So I could use the reverse chain rule to say that this is going to be equal to the natural log of the absolute value of the thing that I have in the denominator, which is f of x, plus c. And that is exactly, I made it too wide so you can't see everything, but that's exactly what's going on right over here. I have, if I say that this thing right over here, if cosine of x is f of x, then sine of x is not quite the derivative, it's the negative of the derivative. So f prime of x would be negative sine of x. So how do I get that? How do I engineer it? Well, what if I just threw a negative there and a negative there? So it's essentially multiplying by -1 twice, which is still going to stay positive. So now negative sine of x right over here, I'm trying to squeeze it in between the integral sign and the sine of x. This right over here, now that I put a negative sine of x, that is the derivative of cosine of x. So this is f prime of x. So I can just apply the reverse chain rule. This is going to be, we deserve a little mini drum roll here. This is going to be equal to the natural log of the absolute value of our f of x, which is going to be cosine of x. And then, of course, we have our plus c. And we can't forget, we had this little negative sitting out here. So we're going to have to put the negative right over there. And we are done. We just figured out, and that's kind of a neat result because it feels like that's something that we should know how to take the indefinite integral of. The indefinite integral of tangent of x is, and it's neat that these are connected in this way, is the negative natural log of the absolute value of cosine of x plus c.